This
Hi
conference
SQL
will
folks.
now be recorded.
Hi SQL folks. Myself Rajshekhar Reddy Bolla from Next Generation SQL DBA. So today I want to talk about the top operators in the execution plan. Okay. So the top operator, one of the most dangerous one is table scan. Table scan, cluster index scan, key lookup, row ID lookup. Let's talk about on these things. Okay. So one of the most dangerous one is table scan. Okay, so this consume lot of CPUs, memory, and all thing, and lot of IO. huh? When table scan, you can see in a execution plan is huh, when you don't have a index on the table. That means the table, if the table is a heap, then you can see this kind of table scan. Okay, mostly if you don't have a clustered index team for every like no clustered index as well as no non-clustered indexes also. So if you don't see those indexes, you can see table scan. Let me run a query. huh? So just selecting this table type, person is a schema, person one is a table. So just checking alt F1. Alt F1 means table properties. Okay, if you see here, there is no indexes on this table. Okay, there is no indexes on the table. If you run any query on this table, see what will happen to. So for finding the rows, email promotion equal to 1, it is uh, finding the data of business entity ID, first name and last name, who having the email promotion equals to 1. So to find the data, what's happening? See the execution plan. You can just select this one, actual execution plan. So that while executing the query, it gives the execution plan also. Okay. See, if you see the execution plan here, table scan. Table scan means like for finding these rows, for finding this data, it is scanning entire table, all the columns and all the rows. It is scanning and finding the data. Okay, the in real time. Okay, this takes lot of time, lot of CPU memory consume. It takes lot of resources time. How to avoid this? Huh? So to avoid this table scan, uh, people can recommend you, okay, create a index on this email promotions. Okay, so see, to satisfy this query, uh, you can create a index on email promotions one. Uh, Suppose we have another query, another filter column like first name equals to so and so, and city equals to so and so, and business entity equals to so and so. See, if you are keep on adding the indexes like this to a table, what will happen? Huh? So more indexes also it creates a lot of issues. I mean, DML queries, insert, updates, deletes, those queries slow down thing. Okay, so I recommend you don't create so many indexes on a table, especially in OLTP environment. Okay, in OLTP environment, yes, it's required to create some indexes. Otherwise, what will happen to hmm? for retrieving the data? It takes more time. See, like this table scan. So it's a small table, small size database, small table. It's not taking time. But if it is a bigger size database, it definitely takes a lot of time. Okay, that leads to locking, that leads to blocking. Okay, sometimes blocking also leads to deadlocks. It's all coincidence, one to each other. Okay, so to avoid these things, this table scan, I recommend you to create an index on the email promotions, but you cannot create indexes and like to satisfy all such kind of queries. You cannot add an index on such kind of filters. In such case, what you can do, you can create a clustered index. Okay, so in real time we don't create any clustered index, we all know that. So if you see alt F1 like properties of the table, so in general in OLTP environment, OLTP means the data the data and all normalized, the tables and all normalized. Okay, the small subset of the data divided, and we will create a smaller tables. Yes or no? Employee table. Employee table, we cannot keep it in one table. So employee address, employee hikes, like that we will divide. Why we should avoid? Why we should divide like that? To avoid the duplicates. Huh? To avoid the duplicates, repetitive data, we have to normalize. Huh? In the process of normalization, we will make into multiple tables. And if you want to get the data, again, you have to join the tables. Huh? If you are joining the tables, getting the data from multiple tables, definitely you need a index. Okay, definitely you need a index. So to satisfy all these filter columns, uh, we have one great thing is clustered index will satisfy all these kind of filters. Clustered index is very important for a table team. Okay, so I can say clustered index clustered index is also a one of the table. Okay, so see, hmm? See, there is a table, right? Okay, so this is a some person table. If you create a clustered index team, there is a kind of a another table will be created. This is a clustered index. Okay, if you don't have clustered index, what will happen team on this table? TableScan will happen. If we have a clustered index team, if you use any filter column, uh, whether business entity ID, where city equals to so and so, where email promotion equals to 1, for all those filters, it will use the clustered index. Okay, so clustered index is far better than TableScan. Huh? Really, clustered index, it does the really wonders. Huh? So team, I recommend you, huh, please be create. If you don't have a clustered index on the table team, from today you can just check it and create clustered index for all tables team. Clustered index is really important. I'm working currently on 40 terabyte database team. So clustered index helps in many ways. Okay, so I cannot include all the, I mean, I cannot say all the benefits and all here, but in terms of the performance team, so clustered index helps a lot. Let me show you team, like we have a same table, person.person. So this table, we have a clustered index on the business entity ID. Okay, let me check it. Alt F1, properties of the table. See, if you see here, see, we have a clustered index. Can you see? In business entity ID, we have a clustered index. Huh? If I run the same query team, what will happen? Huh? Earlier, it is TableScan, right? Now let's see. See, clustered index scan. This is far most better than the table scan. So it scans only the clustered index. That means clustered index having the all the data of this table, not only business entity ID team. Okay, it maintains all the other field, other columns data also. So that's why it depends on the clustered index scan. Okay, so what I am saying team, so like person one, we don't have a any index. Person, yes, we have a clustered index. To satisfy this query team, I'm saying team, hmm, so we cannot create indexes on all the columns like this, because if you are people are running lot of queries on the table. Okay, for all filter columns, for all the queries they are running, we cannot go and create a separate index. It's really tough. So my recommendation is go and create a clustered index that satisfy all the queries. That's the important one. The next thing, after creation of the clustered index, okay, so after creation of the clustered index, then just check it, in a table how many indexes are there. Okay, just check it, how many in the table, how many indexes are there. If a table having indexes of more than 5, don't create any indexes on the filter column. Just what I am saying then, per a table, see, in real time you can create more than 1,000 indexes for a table. But if you create 1,000 indexes, what that won't be a OLTP database. That will become a OLAP database. Okay, so we never create that many indexes in real time team. Up to 5 or 6 indexes you can create in real time. Don't go beyond that. Okay, so if we have indexes like this 1 2 3, yes, like 1 2 3, yes, you can create one more indexes also, one or two indexes. So what are all really required for those queries only, you can create an index system up to 5 or 6. Beyond that, don't go. Okay, so if you compare these two queries team, see here, I'm just checking the execution plan for both the queries. We have same data for both the tables. See here, the execution plan is showing 50%, 50%. But if you see like CPU, memory, IO, this consumes very less comparatively this one take. So if you want to set IO count on, you can check it like that. So you can see that difference between these two. Okay. See here, there is no index recommendation here, but here it is recommending a index. Okay. So see what I am saying. So this query, very poor performance. This query, a better. But I want to improve like more. What you can do, you can create an index on this column, this filter. Okay. So how to create an index on this one? So we have a formula always thing. So for any table, divide like this. Okay. Table name, filter columns. Okay. And select columns. Okay. So table name here is person, right? Okay. Person. Filter column means like where class column, join class columns, order by columns, in, if you use in, so that is also like that column, that's also filter a column. Actually in a table we have like millions of rows, million rows, nobody will read at a time. They read whatever the required data. So we need to filter. So that filter columns you can keep separated by column. So here we have only one filter. I am using email promotion. And select columns. Select columns are this. Okay. So like this you can give. Now you can create an index. How to create index? So create. Okay. Uh, non-clustered. Okay. Index. Create non-clustered index. Index name. Okay, on table name. Okay, so here you need to give filter columns. So DBS are like CT. So nowadays, like we have a artificial intelligence. We have ChatGPT, Gemini, okay, Copilot, and all them. So it's easy like to get the code. Whatever the errors you have, like you can give it. It will give the solution and all. But our SQL DBA guys, the nowadays the toughest thing is to resolve the performance issues. If you give like your problem and all, it won't give exact reasons and all, the chat GPT, Gemini and all. Further, like you have to do manually. Manual analysis is really required. Okay, so you should be good at performance tuning team. Then only you can survive in the future. So performance tuning is really very much important in nowadays and in coming future. Okay, so most of the work and all can be done by the so artificial intelligence itself. That's why you have to shift it to, at least you have to good at performance tuning and all team, so that we can survive in the market. Yeah, so create non-clustered index name on table name, filter columns, include select columns. Okay, select columns. So this is the formula to create an index on any query. Okay, so team, there are some conditions team, like filter columns, like you cannot use some functions if you have that won't use exit, that and all we'll talk later. Okay, in general, so we have to use this formula to create a index team. So take this. Okay, this is the table. Okay, what is the filter column? Email promotion. Just take it. Okay, and business entity ID, first name and last name. Just take it and paste it. Okay, some name you can give. So always naming conventions are very important. If it is non-clustered, so you can give any naming, like so by seeing the name, like people can think of it's a non-clustered indexes and all. I am following like this. So non-clustered indexes on person table, and on which column? Email promotions, and also these columns included. Okay, so if it is like big, the name is, you can make it small also. Like instead of first name, uh, so just give like first name, something like this. Okay, make it, don't give big name. Hmm? Yeah, so like this you can create index. Huh? So team, huh? I want to tell you one thing. See, this is a, we have a clustered index on this table, on this column. Okay, you don't need to give, this column name. By default, it included for every non-clustered indexes. Every non-clustered index includes the clustered index also. Huh? So if it is give also, that's fine, no issues. Yeah, see, we have created a index on the, to satisfy this query. Let's see now. Okay, so what will happen? See, earlier clustered index scan. Now if you run this query, see, index seek. So this is 100% satisfying this query thing. I mean, if you see the performance difference thing, just take it, new query window. So the first one team, we don't have any indexes at all. Okay, so this one we have a clustered index. Okay, so instead of table scan, it will use the clustered index scan team if you don't have an index on this email promotion. Now we have created a index on the email promotions. If you see the execution plans team, see here, you have to add the actual execution plan and execute it. Okay, see, 1%. So like this, you have to create the indexes in real time team, so that you can avoid a table scan, clustered index scan also. Okay, clustered index, see, 1%. That means team, like this query, suppose it is taking to retrieve this data, suppose it is taking 900 seconds. So in 100 seconds, this query takes 99 seconds to retrieve the data. The same data, this one, it takes only 1 second. See, that much improved, 99% improved team, this query. Even CPU, memory, IO also improved. Okay, so I didn't use set IO count on and all team. So if you want, you can use set IO stats, right?
This conference will now be recorded.
See, I'm just including so how much IO and how much CPU consuming in the background and all thing. So let's run this now. Okay. So this will give the compile time, execution time and all. See the last one, see logical reads. Logical reads is just 31 only. Okay. Here logical reads 3811. So physical reads 0 10 because so we ran almost more than one time, right? More than one time means the data and all will be stored on the memory itself. So in real time team, okay. So how the data will be stored? See, we have a CPU, okay. So we have a drive, okay. We have a drive or a disk. huh? So directly CPU cannot take the data from the drive. It cannot take because CPU is jet speed, high speed. huh? So drive is dead slow. So to compensate the speed between drive and CPU, we have a memory concept. Okay, so memory is costlier comparatively drive. So CPU wants some data if you are running any query and all. So select queries, update, delete queries. It checks the data in the memory. Okay, it checks in the memory. If it finds the data, it gets the data to the CPU and it processes it. See, this is called logical read. Okay, logical read and logical write. We call it as logical read, logical write. So suppose that the data doesn't find here, doesn't found here. So it gets the data from the drive. Okay, this we call it as a physical read or physical write. See, logical and physical. Physicals are dangerous. Okay, because it's a slow, right? Comparatively, the speed of the memory. So if you see physical reads and all team, like maybe there, what you can do, you can create some index team. That index data will be copied into the memory. That's how you can save these physical reads and writes. Okay, so comparatively physical logical reads or writes are good. Okay, so that's the difference of logical and physical. Okay, so if it finds the data in the memory, that we call it as a page life buffer cache hit ratio. What we call it as buffer cache hit ratio. If it finds the data, then 100% yes found. If it is not finding the data, it has to get it. So you can also check the performance of SQL Server using the buffer cache hit ratio. So like if it is not buffer cache hit ratio is 99% less than of 99%, then most of the data are not finding in the memory, and it is always going for more. I mean, physical reads are happening and all. Okay, so to avoid this thing, suggesting you create a clustered index along with clustered indexes up to 5 or 6 indexes, the most really required indexes you can create, so that buffer cache hit ratio and all will be improved, like it comes to near 100%. And also you can avoid physical reads and all. And also like how much the data and all storing in the memory itself, right? So that we call it as a page life expectancy. The data and all placed in the memory. uh, so how much time the data is staying in this memory? uh, so it's staying more time, more page life expectancy. I mean, a more time it is staying. That means that's good. Okay, so that's how the memory pressure and all we can check in the SQL Server team. There are a lot of things to discuss internally team. Like this is basic. So if you want to improve any queries and all team, though you are not a proficient in performance tuning, just follow this simple technique. Huh? What is the simple technique? Run a query. It is happening. Table scan is very dangerous thing. The most dangerous thing is table scan. After that, clustered index scan. Clustered index scan is good thing comparatively table scan. See, I told you, right? For every query, you cannot create an index. Okay. In such case, clustered index scan is happening. That's fine. Leave it. Okay, so leave it. So if you want to really improve that query, there is a pressure on you to create an index on that, then go and create a index on that specific column, then avoid the clustered index scan. That will become index seek. So I showed you, right, the example. The other one is the row ID lookup. This we will talk in the next video. Okay, so if you don't have a sufficient index, I mean, see, we need to add a indexes. See the example. Email promotion and included columns. These are all. Like suppose the insufficient index we have, something like this. Then there is a chance of key lookup. Key lookup and row ID lookup. If you don't have a cluster index, row ID lookup. If you have a cluster index, then key lookup you can see. That we will discuss in the next video. So what is the conclusion here is, like if you are checking any execution plan time, just avoid this table scan and the clustered index scan. If you say, just avoid them by creating a sufficient exact index to satisfy that query, like filter columns and select columns. Select columns also very important thing, so that it avoids the key lookup and row ID lookups. Okay, yeah. Thanks, team. Thanks for watching this video. Yeah, subscribe my YouTube channel so that you will get all the videos, whatever I create in the future. You will get the link, team, in the future. You will get a notification. Thank you, team. Thanks for watching. Have a nice day. Bye.